Structures make easier. A few words about me. I studied at the college of the Slovak Technical University, and I did my doctoral studies. Partially, I worked also on the Cathedral of concrete structures. I'm an authorized engineer. I work for ConIS, and recently we merged, or we got into a partnership with Tsukon, where we share our workflows and design and new ways of working together. So today we'll be talking about the structure calculator, how to create an analytical model, the MKP analysis, automation, and the possible futures. I don't want to say right, but the people who calculate the structural calculations, they were the first that used BIM models because they used it to their benefit. So they were probably the first, and now we are trying to use these 3D models and extend it with the results of the analysis. Of course, it's about data exchange, about having a shared data storage, and then we can see the statical load and also the dynamic load from technologies. A very interesting function in BIM is that we can have a single model, which is a single source of truth. Normally, the people creating these calculations, they have to use various sources. So how does it look like? So ideally, we should not do the word. We should not repeat the work of others. For example, also in terms of or improving the coordination and improving the coordination during the processes and after the processes as well. So what are our ways of joining our work with the design model? So ideally, we, the structural engineers, should be at the very beginning of the process, and we should be able to be present in the design stage. Sometimes we are unable to do that, so there are three other options for us. One, that's the modification of the architectonic model. That means we will take the model, reduce it to the load-bearing structure, and then modify that. Or the second option is, and this is a preferred option for us in our company, is a copy monitor. That means we copy that and then monitor it, and then the third one is working on one shared model. This requires more resources, hardware resources. Usually, it's not that difficult in terms of technology, but it makes things difficult in terms of legal responsibility and accountability. If there is a mistake or an error made, usually it's difficult to find out who made the mistake. So here you can see that we should be able to, or this is the copy monitor option. This is how we work. For example, the designer needs to know that this is a wall from concrete, but we can make it more detailed. We can add, let's say, the concrete class, then influence of influence of some other elements. So we just say what we need to copy. But what is important is that individual parts are monitored, and we also change, or we also monitor any changes. So we are starting not with creating the model, but rather with just modifying the model. You can see this 3D, 4D, 5D. At the moment, we are at the 6D because there is the analysis of sustainability. And again, we have something as a template. We have a certain shape of the structure, and we need to have a simplified model. We don't want to create a new model. And here in this video, you can see that I just identify elements that I want to work with, and I don't start creating the analytical model, but I just modify it. I'm happy that Revit, that we have Revit, but there are also some competitors that are able to or competitors that have that produce some softwares and softwares that we can use.
One module, one source of truth. The global module would have many elements. In this case, if there was a very dense network of final points, and therefore we do have various submodels. I don't need to have it in 50 different files. There are individual submodels for the towers, for global module, for different components. And the great thing is that we can load the results either from the global module into the database, and then we can use the results for designing hubs or for metal connectors. And MKB analysis provides interface or connection to all main solutions of BIM, and you should think about selling the piece of information well to the architect. You need to be able to demonstrate how the construction is actually behaving. For instance, when a vehicle goes over it, and then you will be able to provide the architect with the technical information, such as what should be the reinforcement, etc. You need to be able to create your own script. There should be a blade or a surface that should have a reinforcement, and it should be a specific type of surface, lighter surface, and then there is a script that offers you different combinations. The system evaluates each and every element and then assesses whether it fits our requirements or not. This could be an iteration type of process. This is a partial module, and you see that in specific parts of this plate or the strip, certain components couldn't be made from lighter materials. They should have been made from the standard typical materials. We see different drawings of reinforcements, and at the time of swift exchange of information, this is totally necessary. The script created by Marek Czuchak from Tukon that generates the basic grid of reinforcements. And I definitely would recommend any structural designer to choose a software that allows for creating such scripts. You shouldn't go over technical, so to say. We have different categories for slabs, for walls, for supportive walls. You see the basic grid, and we filter one direction of reinforcement that can be further divided into different directions because the components can go only in one direction, and because the rods can go only in one direction, and you can play with it. You go to the scripts of description or the reinforcement, and then we are a controller here, not a mere operator of the system. We, for instance, indicate which wall we want to reinforce. We what is an advantage in the scripting is that you do it for your own needs based on your own standards. That means you don't need to rely or wait for an update from a software company. It is very good to be able to work with this from the perspective of time efficiency, overall efficiency, and if you are if you don't need to spend time on this very repetitive type of activities, you can focus more on designing. Of course, the final responsibility lies with the designer. You can never blame the software, but in this case, the script was made by you. You see multiple scripts combined here, and how do you frame the slab? How do you frame the wall? And if you have segmented it well enough, you have a good overview of what you are doing, and you don't get stuck. You shouldn't be trying to have a master button that you would just click and all of a building or construction would be reinforced. But you need to go script by script and indicate which slab or wall you want to reinforce. You enter certain parameters and then the script runs. It is exactly according to your needs and desires. Construction detail, the rods, the way of reinforcement, that's everything up to you. What are the concrete examples? So one complex model that you have analytical model, constructions, databases, and then at the end of the day, the reinforcement and connecting parts to whatever we talk about, underground garages, apartment houses, anything. And what is the future? Definitely AI comes on stage. Maybe individual phases of construction will be connected according to the construction plan. So we will connect the technological part, because with the bigger objects where the dilatation holes are somehow connected, we need to focus on the holistic picture, as you can see on this short video. You only in this picture you see that you only define the you define the load, and then you enter further specific parameters, and then it calculates it and offers you this holistic vision. Thank you very much for your attention. Thank you.
Takže ďakujem za pozornosť.